Hello, thank you for coming to this talk. So today I'm going to be talking about practical Wi-Fi hacking, or how I think you need to hack Wi-Fi in 2018. If you read stuff on the internet, there's a lot of approaches that people talk about that are dated. They're not sort of up to date with how modern enterprise Wi-Fi access points are deployed, or how you'd hack modern enterprise Wi-Fi. So this is what this talk's about. So in 2014, I built a set of tools that we call the Mana toolkit, which is about rogue access point attacks. This is also about the updates that we've made to it since. So my name's Dominic White. On Twitter, I'm @Singe, which turns out means something in French. I only found that out recently. And I work for a company called SensePost. We're a South African penetration testing company. It took me 36 hours door to door to get here. Yeah. So thanks for having me. And I did this talk in conjunction with a colleague of mine who's not here, a guy named Michael at SensePost. So if you want to say nice things about this talk, please do it on Twitter. And if you want to tell me I'm wrong and you hate me, do it on email. Yeah. All right, so to make your life a little easier, if you want to get access to all of the tools I'm talking about, you can go to that URL, wifi.net with a 1. There's a link to a wiki, which has written up a bunch of the how to do these things. So I'm going to have a little less of the technical type this into your command line here, and rather tell you why you'd want to do it and what you'd get out of doing it. And then you could look at how to do it on the website there. Okay, so I've broken this talk into 3 scenarios because I think it's a nice way of talking about the ins and outs that you'll have to deal with when you're doing Wi-Fi hacking in those scenarios. Now, you might not be in exactly that situation, but hopefully you can take away the points I'm trying to make about if this, then that, and to apply to the situation you're in. Because I think a lot of the time, people don't take the time to figure out what's going on when they're doing Wi-Fi hacking. So you just download a Python script, you run Wi-Fi, you run EPAMmer, you don't know what's going on underneath, and then stuff doesn't work, and you're like, oh, well, there's no vulnerabilities. But actually, if you understand what you're doing, Wi-Fi is a really, really vulnerable and poorly deployed in general infrastructure, and you can get a lot out of it. For red teaming, for penetration testing, it's the gift that keeps on giving for me. So since 2013, I use this in every engagement, and it nearly always gives me some joy. Okay, so the first scenario is about tracking. Has anyone ever played with something called Snoopy? It was a toolkit released in 2011 for tracking devices around. So anyone recognize it? Okay, well. So the idea was that, and you'll know this if you've been playing with Wi-Fi, that when your devices look for networks nearby, they send out these probe requests, and those probe requests can tell you where that device has been. So if Sagi's phone is probing for what's something suitably inappropriate, Bob's House of Pain Emporium, then we can tell that Sagi at some point went there. And if it's telling us it's probing for something in the UK, maybe go in flight, I can start to build up a picture that he's been on a plane, things like that. So what happened was manufacturers have changed the way devices probe so that it's harder to identify devices because of this randomization. And so so Snoopy's dead. That kind of tracking, looking at MAC addresses and probe addresses to track somebody around, doesn't really work anymore. People have built defenses against it. And so the way you can now track people around, you need to bear some things in mind. So this is a screenshot from a tool called Wi-Fi Explorer. If you want to learn how Wi-Fi works and you have a Mac, this is a fantastic tool. It's fairly inexpensive for the entry-level version, and it just gives you all sorts of fantastic information about what this thing is and how it works and stuff like that. Okay, so this is obviously the networks around here. Not right at the moment. This was in my room earlier. And if you check, the top's got 2.4 gigahertz, and the bottom's got 5 gigahertz. Sorry, I didn't start my timer. Start that. And when you look at a picture like this, you get this idea that, okay, there's a little bit more 5 gigahertz spectrum, but it's sort of roughly the same size as the 2.4 gigahertz spectrum. And if you've ever done passive Wi-Fi hacking, where you're sitting there hopping across channels and monitoring stuff going on the network, there's about 13 channels in the 2.4 gigahertz range, and then there's a bunch more channels in the 5 gigahertz range. So if you're going to do passive monitoring on 2.4 gigahertz and 5 gigahertz, you're like, okay, it's going to be a bit more work. Maybe slightly more than double, based on this picture. In reality, that's how that stuff looks. There is way more 5 gigahertz Wi-Fi spectrum than there is 2.4 gig Wi-Fi spectrum. So you can't, with one card, practically channel hop through all of these and hope to see some kind of reasonable interaction. Every couple of seconds, you'll be on a channel long enough to see something. And so That's where things like the Wi-Fi cactus come from. If you want to practically monitor across all of these channels simultaneously, you need crazy stuff like the stuff Dark Matter built. Now, most of us, on the one hand, it's a lot of work to build, and on the other, you're probably going to look suspicious if you arrive at a client with that on your back. Yeah, I'm just here to check the plumbing. So if you want to do Wi-Fi hacking and this is all you have, then you need a way to attract devices to you rather than having to monitor the whole spectrum. And that's where rogue access points come in. By running a rogue access point, devices have algorithms in to find nearby access points because they've got the same spectrum problem. It's not like your iPhone can monitor all of that spectrum with 100 radios. It's going to go, show me where the Wi-Fi networks are based on beacons coming out from these things. All right, there's one. I'm going to send a broadcast probe request at that and see what it responds with. So the general theory is don't go to them, make them come to you. And rogue access points, for this reason alone, rogue access points are almost essential for modern Wi-Fi hacking. If you think about it, if you want to capture WPA2 handshakes, you've got to de-auth them off their enterprise AP, and you've got some crappy little antenna, and they've got fancy Cisco Meraki kit or Arubas or something like that. If you want to monitor a bunch of spectrum, if you're just pretty much anything you're doing, you run your own AP, the devices will come to you, and then you can manipulate the clients. So if you run like an evil twin attack pretending to be a WPA PSK network, you can capture enough of the handshake to crack those credentials. You don't actually have to capture the handshake when it connects to WPA2 AP. And that's great because it now also frees you from the restraints of having to be near the actual access point that you're targeting. You're now targeting clients. So I can start targeting people in this room instead of having to go to their places of work to target that. Or you can target the nearby coffee shop. So be an AP. Now, the problem we have with the tracking in particular is this anonymization thing. So the MAC addresses are randomized every time they probe, so you can't tell from one probe to another, is this the same device? And then the other problem that you have is they're not probing for the specific network anymore. For the most part, what modern devices will do is they'll say, hey, Wi-Fi network, what Wi-Fi networks are out there? Then they'll match on an internal list privately whether any of those networks are on their P&L, their preferred network list. So if you imagine your device auto-connects to work when you get to work and home when you get to home, it'll arrive in a place, it'll say, hey, Wi-Fi networks, what are your names? And something says, well, I'm home, then it'll probe for home. Something says I'm work, then it'll probe for work. It's not going to reveal those probes proactively like it used to. So that's why I say Snoopy's dead. So the problem we have is we need to de-anonymize these devices if we're tracking them. And there was some fantastic work by a guy named Denton Gentry, he's an ex-Googler, where he came up with a signature of unique aspects of Wi-Fi interactions, and he calls it Wi-Fi taxonomy. So based on the extensions, the HF extensions, or their specific aspects of how that device probes, you can create a unique signature. And then you can de-anonymize devices. Can you tell that I drew that myself? So let me give you a practical example of what that looks like. So I'm using Maltego here, and I've taken the raw output from Mana and shunted it into Maltego. I haven't manipulated this file at all. So this is something that's really easy that you can do. So let's say we see 4 devices, 4 different MAC addresses, and they're probing for a network called Internet. Now, the reason we can see their probes with Mana is because I'm an actual access point. They'll send a broadcast probe at me, and I'll respond saying, hey, I'm this network. So the trick is, how do I know to respond as Internet? Well, maybe it's just a common SSID that will be included in there. Or with loud mode, what Mana does is it learns the names of networks from devices around it. So maybe you've got an older tablet that's still probing for network names. The second it sees that, Mana will rebroadcast that network name in response to a broadcast from someone else. So Mana is really good at figuring out network names nearby automatically and then broadcasting those to people. I'm not going into that too much detail because that's kind of standard. Like our talk in 2014 went through that. Okay, so let's say you've got 4 devices. Now, some of those are randomized MAC addresses, some aren't. We don't really know. How do we de-anonymize them? Well, the first thing is let's add that markup. What's random and what's not? In Mana, there's just a CSV that it outputs with a 0 or 1, whether it's randomized or not. So because randomized MAC addresses have the second bit of the first octet set called locally administered MACs, we can tell whether it's randomized. But that still doesn't help us because we don't know, so because there's 2 non-random devices, we know there's at least 2 physical devices. But which of those random probes belongs to which of those physical devices? And are those random probes even associated to those physical devices? They could be from other devices that we don't have here. So with the taxonomy stuff, you can effectively de-anonymize this. So we can see that there's two devices. The one random probe belongs to the one device and the other one to the other. So with these taxonomies, we can effectively come up with unique signatures per device. So Mana supports all this stuff. What I did is I took Denton's work and I extended it to work pre-association. So he would only generate these signatures once a device had associated to the network. I generate the signatures before the device associates to the network so that you can de-anonymize devices and track them around. So this is really good in the beginning where you're just trying to figure out what's going on, or maybe there's a particular person you want to target. You want to see are they using Windows device or a Mac, because they've got different sort of randomized probing behavior. And like I said, there's a whole bunch of things you'd need to do to make this work. Well, not a lot of things you need to do to make it work. And I put it all in a wiki. I decided to write documentation for a change. It's rare for me. So if you go to that wifi.net website, on the top right, there's a link to the wiki. And it's got detailed information about how to configure this. But people get really confused with host APD and its configuration files. Normally because the default configuration file is about 1,200 lines long, and people look at it and are like, "Rrr." So this is, with those 4 lines, you can run an access point with host APD. Vanilla host APD. You just give it a channel, you give it a network name, you give it a device and a hardware mode. You need to have a Wi-Fi adapter that supports master mode, but away you go. 4 lines, you've got an access point. You want to run an AP at your house? There you go. 4 lines. Stop buying D-links and things like that. If you want to enable Mana's basic options, you add those 2 commands there. So enable Mana will respond to people's, so it's effectively the old Karma style attack, but it'll do it at a probe level. And then loud mode is that thing where it learns from the networks that are nearby and rebroadcasts them to other devices. So there you go. You've got modern Karma attacks working with 2 extra, for the cost of 2 extra things. If you want to log this stuff to a file and do the taxonomy tracking, then it's these 3 extra lines. So for the cost of 9 lines, there you go. You've got an access point that can do all of the stuff I just spoke about, and it dumps it to a single CSV file. You don't have to be like a crazy Unix guru to parse CSV files. So yeah, people, I don't know why they get really scared about host APD, but it's actually really simple. Okay, so the next scenario would be enterprise networks, so things that are using extensible authentication protocol, EAP. So the most common one being PEEP, or some people will have EAP TLS where there's certificates involved. And so the most common attack in that is the evil twin attack. Is anyone young enough not to get this? This is Spock's evil twin from the what dimension? Come on. The which one? Mirror universe. Thank you. I knew that I'd have a fellow Trekkie in here. Okay, so the one stuff that just triggers me a little is I read these write-ups about how to do evil twin attacks, and people are like, yeah, you just use your alpha card and you make your network name the same as the enterprise one, but you make it an open network. Like Wi-Fi Fisher, the principle is that you make an open network of the same name as the corporate one, and then you pop up a captive portal and people type in their creds. The problem with that kind of stuff is, like I said before, you're racing a corporate access point. And for a fairly big company, they're going to have sometimes hundreds of access points. They've done Wi-Fi surveys. These are fancy antennas with decent power. And you're coming along with your crappy alpha card that's probably behind a table somewhere. You're not going to have the same sort of access to spectrum and quality signal. And then, so this device will automatically connect to a network in its PNL if it looks the same. So that means it's got the same security options. So if you're popping up a network that's an open Wi-Fi access point, it's not going to automatically connect. So somebody has to pick up their phone and click on it. But why would they do that? Because their device is already on Wi-Fi. So now you've got to de-auth them off their existing Wi-Fi. But because there's 20 access points, you have to try and denial of service everyone on their Wi-Fi. And then not even the security guys, the network admin's just going to come hit you with a stick and say, stop it. So it's not particularly stealthy. You've got wireless intrusion prevention systems that come along and it gives you a bad time. Now you can do this, but just make your life easy. Go buy an enterprise access point, an Aruba or a Ruckus. Or hell, steal one of theirs, reset the firmware, and then make it talk to your Mana. Mana can run as a standalone Radius server. It can talk to that, and then it can capture the creds that way. But still, you've still got to deal with all of the potential of getting caught. What's much easier, and I mentioned it earlier, is don't race their enterprise AP. Do it at the nearby coffee shop that they all go to. Somewhere where they don't have Wi-Fi coverage, but their employees are, becomes a target-rich environment. And if you run this stuff on a Pi with a battery, you can leave it there for a couple of days. You don't need this to be with you the whole time. Okay, so the way that stuff works is I stole from a guy named Brad Antoniovich and Joshua Wright. In 2004, they wrote Free Radius WPE, Wireless Pwnage Edition. Is anyone here familiar with Celeste Barber? Yeah, Celeste Barber is awesome. So she does these rip-offs of celebrities. Celebrities were trying to look all cool, and then she'll be there in her underpants with like a bottle of wine, recreating the same picture. So this was like one of the few of her not in her underpants. And so the Free Radius WPE stuff that Joshua Wright and Brad Antoniovich did in 2004, they're like the Justin Bieber. I'm the Celeste Barber to their Justin Bieber. So we've implemented WPE stuff. I've still called it WPE as a homage to the work that they've done. In Mana, that's been there since 2014 when we first built Mana. But I've now extended it and taken it quite a lot further. So on the one hand, I've just cleaned up the output, so it'll neatly output John hashes or hashcat hashes or give you the asleep command and stuff like that. So you don't have to, people had scripts for turning it from one hash to another. This just gives it to you. And the other cool thing is it does 13 different EAP modes. It's a bit of an eye chart, it's on the wiki. I mean, realistically, you don't run into this, but it can do GTC, it can do MD5, it can do MS-Chap version 1, MS-Chap version 2, it can do PAP, all of that stuff. So there's a pretty good chance that for whatever EAP mode you're going to run into at a client, it'll be able to intercept the credentials or the hashes, and it'll dump it out in a nice format that you can just auto-send to John and Hashcat. But this is realistically, it's just the same functionality that's been in WPE or HostAPD WPE for a couple of years and in Mana. And to enable it, it's just that single command at the top in your HostAPE config file. Mana WPE equals 1, done. So now you've got 10 lines in your config file. Realistically, you're still going to have to set it up to be an EAP access point with certificates and things. The wiki's got information for how to do that. It's really not too complicated. You just need to generate a certificate. But I'll tell you, I'm going to go into certificates shortly because there's some nuance there. Okay, so this is the way PEEP works. As you can tell, this is a highly technical diagram taken from the IETF. And essentially, PEEP stands for Protected Extensible Authentication Protocol. And the protected part just means it's wrapped in TLS. So there's this internal MS-Chap exchange. No one really cares that it's MS-Chap because the security comes from the TLS outer tunnel layer. So this is a type of tunneled authentication protocol. What that happens with TLS is much like your browser would. If you connect to a website, a certificate's presented to your browser makes some decisions based on the validity of that website and then goes in. Did anyone here watch Parissa Tabriz's Black Hat keynote? Anyone? Anyone here familiar with Parissa Tabriz and the work that she's doing at Google? Okay. So Parissa Tabriz runs like Project Zero and the Chrome security team. So she's quite a legend. And they embarked on this like 2-year project to fix the iconography around SSL on the web. They were like, how do we display the right things to users that make them make the right decisions? Now, if you think about in a web browser, it checks that the common name of the certificate matches the host name that you're connecting to. It checks that it's signed by a valid certificate authority. And there's some other checks, like time checks, things like that. In Wi-Fi, you don't have any of that stuff. So this is an example of so Defcon runs their Wi-Fi network, and they give you all these configurations to make sure that if you connect to their Wi-Fi, that stuff's protected. So they bought a certificate from DigiCert, so that's the one on the left. And on the right, I used a tool of ours called Apostille, it's on GitHub/SensePost, to just clone the certificate chain of that. So now there's different behavior on different devices. So on a Linux or Android device, the way you validate that the access point you're talking to is legit is based on the CA server. Now, unless you provide that line, it doesn't happen by default. You have to say, hey, check the CA certificate, make sure it's legitimate. Does anyone see a potential attack you can do against something like that? It's a publicly bought certificate. So you can go buy a cert from DigiCert, and now you too can run a legitimate access point. And that's like all of Linux and Android, unless they've built additional supplicant things. WPA supplicant, which is the way the client associates, has no ability to look at the leaf cert. It can only look at the CA cert. So you literally can't secure against, if you bought a DigiCert global certificate, well, a DigiCert signed certificate, you could have gotten access to any network that's using PEEP on a public AP. And this is if they've configured it that way, because truthfully, most of the time users just click on things, right? They're not setting things up that way. Then in Windows, by default, also doesn't validate, but you can also validate on CA. So you might be familiar in Windows, you can choose which certificate authority. So most of the time, people use an internal PKI, and they'll validate on that CA. That's pretty good. That'll save you. But if a user hand connects to this thing, because it's not something you can enforce server-side, it needs to be done per client. And the second we get patching right is the day I'll believe that we can get this right across all clients. Realistically, some user's going to click on your network and use it without having gone through your certificate validation thing. And you can go after those people. And maybe their laptops are configured well, but their handhelds might not be. And then Mac is a little better in that it'll look at the exact cert that's prevented, and if it connects to that network again, it'll pop it up and make the user decide, which at least gives you the option, but it doesn't like say, hey, the cert's changed, or you should watch out for this, or this is how you could validate a cert on Wi-Fi. So if on Mac I was presented with a certificate like that, I'd be like, yeah. And even a validly signed certificate, so a certificate signed by a valid CA on a Mac, it'll still prompt you, because there's no such thing as a signed CA, because a CA can't say that internet is a globally unique Wi-Fi name. You know, the common name on a certificate can match a host name on a web page, but you don't have that with Wi-Fi. It's not like you can get hackfest.ca as a globally unique Wi-Fi SSID that you'll get a certificate for. So you can't match on common name, you can only really match on CA. And then in Windows, you can say, look, match on the host name. So it doesn't validate the leaf cert. But nobody configures that stuff. I mean, I've probably seen this at like 2 of our clients where they've actually configured it, and that's mostly after we've done pen tests where we had findings around it. So you can generally rely on the fact that somebody in the org doesn't have their certificate stuff configured right, which is why the WPE stuff works. And if it doesn't, then you can just grab the certificate. By watching passively, you can pull with Wireshark, you can see the certificate that goes across, and then just either clone it or make other decisions about what kind of certificate attack that you'll do. And then if they're using internal PKIs, if you can get a certificate from somewhere else. So in one case, managed to phish someone, I extracted their private certificate, so the certificate that would be issued by AD to them, and I used that as the certificate by the AP. And because it was signed by the internal PKI, everyone happily connected to that Wi-Fi access point, even though it was a completely inappropriate certificate. So that stuff can work too. So then the general solution is you should use EAP-TLS. EAP-TLS will save you don't have any of these problems. So EAP-TLS, you've got the server-side certificate, but the client also has the certificate. But the problem is, if you're doing a rogue access point, if they're accepting your invalid server certificate, then you can just accept the client certificate they presented you. So the client certificate gives you trust to make sure you don't have bad clients connecting to your legitimate network. The client certificate does nothing for a legitimate client connecting to a bad network. That's what the other exchange is for, but we've already talked about those problems. So Mana's had, since about 2015, the ability to say, you know, whatever client certificate's fine. So now you're not going to get a password with EAP-TLS, but you'll be able to get them to connect to your network, and you can man in the middle of their communications. They'll think they're connected to the corporate network, and meanwhile you're going after them. And again, this is a single option in Mana. It's mana_EAP-TLS equals 1. So this is kind of standard EAP stuff, but lots of people don't know this. When you see people going after Wi-Fi or building scripts around it, they aren't using these attacks. And this is the attacks that work against enterprise customers. So we then decided, let's see if we can take it a bit further, and we built something called Sycophant. And the idea behind Sycophant is, can we relay the inner MS-CHAP part of the tunneled authentication from a legitimate client to a legitimate access point? And this was somewhat ignorant. We're like, I mean, if we can intercept the challenge response, surely we can relay it. So if you remember, the security of this thing comes down to that outer TLS. So if we bypass that outer TLS and just relay that tunneled internal challenge, that should work, right? We should be able to connect to the legitimate corporate network. And so Michael, the guy who's not here, he built this thing and he got it working, and lo and behold, it worked. And we're like, no, we're definitely doing something wrong. This should not work. Maybe it's our testing setup. And then we went and ran it at a client, and it had worked. And so the advantage here with this attack, what makes it cool, is that you can, for the price of man-in-the-middling the person you're targeting, you can also authenticate to the network without needing to crack that hash. So if it's like a really complicated password, cracking MS-CHAP can take a little longer. Moxie Marlinspike, and I've forgotten the other guy's name, Defcon, I think 2013, showed how you can like guarantee crack that stuff within 24 hours, because MS-CHAP's based off of some DES stuff. But realistically, you're on site, you want to get to the network now. You don't want to wait 24 hours. Well, now you can. You get instant connected to the network. Woohoo! And then you can crack the hash in your spare time. And And so here's just a little demo of that working. So I've actually cleaned up a lot of this. It's not so noisy when you run the actual code. I just didn't get around to recording another video. So this is running Sycophant. So this is the malicious supplicant. And what you can see is a device just connected. We've got the outer identity and the inner identity, which is the domain testing and the user identity, Michael. And then what we'll see is it's now done the inner part, and this is the challenge response, and we're just taking that stuff and we're relaying it to Manna. Sorry, this is Manna side, which has then had the device connect to it. This is Sycophant, getting this the wrong way around. Now, these things actually run simultaneously. Whoops. These things actually run simultaneously. I'm just showing you the stuff broken up so that we can kind of keep track of it. So first we run our malicious access point, we get a connection, and we relay it to our legitimate supplicant. Here we're running our malicious supplicant, and we're actually connecting to the legitimate network with that side, and there you can see we've connected. Now we'll look at the IP address of that adapter. It's obviously not there because we haven't run DHCP, but we are associated to the legitimate network's access point. I'm going to run DH client, and that's going to get us an IP address. There we go. We've got an IP address, and then going to switch over to the browser and make a network connection over there. So this is an actual attack that works. We've used it in a couple of client engagements. If you can get access to the credentials by doing WPE attacks, you can probably do a relay. And this is the kind of thing that's automated, happens instantly. It's a really quick way to get on a network without needing to do too much work. So that's available now. It's called WPA Sycophant. And I asked Michael, hey, this is modern stuff. We need a logo for it. So he's like, I think this logo would be fantastic. And he meant it as a joke, but it's now been immortalized. So this is Squirtle Boy. So also, if you ever meet Michael, or you want to talk about Michael, hashtag Squirtle Boy with an I would be an appropriate way to refer to him. So he's writing and maintaining Sycophant. If you go to that Wi-Fi page, you can grab it. It works with Manna right now, and it works well. So what's interesting about this is in 2002, Asokon, Niemi, and Nyberg from Nokia proposed this exact attack. They said, hey, there's this a risk with tunneled authentication modes that you might relay the inner part. So in 2004, when they actually IETF released the standard, they had a whole section in it talking about crypto binding. So crypto binding is making sure that the outer tunnel, the outer part of the tunnel and the inner part of the tunnel happen between the same devices, reusing some key material between one or the other. So there's a defense against this thing. But what's interesting about it is there's a lack of practical attacks. So the attack's been written up in detail. We found that after the fact. It was built into the standard, so this stuff shouldn't work. Why does it work? Well, so this is a Windows Radius server, and by default, it's got an option to disconnect clients without crypto binding, but it doesn't. So from a server side, you could actually prevent a client from connecting if it doesn't support crypto binding. But by default, you don't do that because people don't want to stop clients from associating to their network. In addition to that, sorry, I see you taking a picture there. Should I wait a little? If you look at a default Windows 10 latest updates, you can also tell your client to disconnect if the server doesn't support crypto binding. But again, that's not done by default. And what we found is that pretty much all clients will not do crypto binding by default. Interestingly, while WPA Supplicant is a bit terrible with certificates, it does enable crypto binding by default. So it looks like Android devices get some free protection because of that, Android and Linux devices. But most of the time, we're going after Windows devices, and this stuff isn't enabled. So the easy thought is, well, if I'm a server admin, I could just tick this box, and away we go. The problem with that is now misconfigured devices can't connect to the network. And as much as we'd like to think that security should be a blocker, it really shouldn't be. You're just going to have people throwing things at you. So this is probably going to exist for a little while. And there were some practical implementations that came close, but nothing that you can run now that you can run end-to-end. So this is the first practical implementation of a decade-and-a-half-year-old proposed idea. So we made the theoretical practical, works really well. Okay, so then the third scenario is Mallory in the middle. And the idea here is once the device is connected, you now want to start doing some stuff. So in 2014, when we first released the Mana toolkit, there was a whole bunch of scripts that would set up networks, that would run SSL strip, and they were all tested to actually work with modern devices so that you could get passwords. And that stuff mostly worked quite well. The problem is it kind of tried to automate a bunch of stuff that, like, if you didn't understand basic networking, you were going to have a bad day. And maybe like using automated scripts you didn't understand wasn't the best idea. So people just like flooded me with help requests of like, what is a DHCP? And I'm like, So since then, BetterCap came along. It's a toolkit built by Evil Socket, and it's awesome. And it just does all of this stuff in a nice Go framework with decent plugins. Everything works. So I've deprecated Mana toolkit, and what I'm saying is just use BetterCap. And there's no magic that Mana does with BetterCap. They just work really well together. If you follow Evil Socket stuff, you'll see he regularly uses Mana to get to an interception point to test things with BetterCap. So they work really well together. Once Mana's running on an interface, you just point BetterCap to that interface, WLAN 0 or whatever. What we're still left with, though, is the problem of orchestrating the networking behind access points. So a lot of what Mana Toolkit was doing is saying, well, like create an enterprise AP or create an open network. And what a lot of the Python scripts that are out there or Go scripts that people are writing are to do that stuff. So if anyone's familiar with this project, Create AP, so it's not for creating evil access points. This is just for automating host AP. And I think it's from it's one of the distributions. Anyway, it works really well. If you need to create access points, like you can run a one-liner, simple one-liner, and you've got an access point. So we thought, well, it'll be really cool if we could use this to do the orchestration for Mana. So, the most important thing is first to name it. So we just called it Berate AP. And like, what's really cool about it is that command, if you wanted to do an evil twin attack, like that's the command that'll do it. Plus, it'll enable Mana. So it'll set up the networking for you. It'll generate the host APD configuration for you and all of that stuff. It's also got other options, so you can do all of this stuff. But the Sycophant stuff's not quite working there yet. It's still a little manual. But it just makes it point and click easy. Not point and click, but straightforward. And you can do this without getting into the guts of the host APD configurations. That said, I would really encourage you to get into the guts of host APD configurations. And don't be scared. Like I pointed out, 4 lines gives you an access point. So this isn't hugely difficult. If you don't understand how things like DHCP work, how networking and routing works, or firewalls work, it's useful to look at the stuff this is generating. It's really simple NAT configurations, really simple DHCP configurations, but it's a nice way to get into networking. And that's part of the problem with Wi-Fi hacking, is it requires you to understand RF, it requires you to understand layer 3 type networking stuff, plus it requires you to understand sort of protocol interception. So there's a lot to get into. So take the automated tools and rather like unpack what's actually going on instead of just going, they'll do the magic for me. And so at SensePost, what we say is, if you don't figure out how a tool works, then the tool's limitations are your limitations. But if you figure out how the tools work, then that tool's your jumping off point for like creating new things. Okay, so by default, Mana is quite a flamethrower. So like particularly in loud mode, it's literally looking at every probe coming from every device around it and is rebroadcasting that at everyone. And it works really well. Like I've spent years now optimizing that to make sure it can reasonably like blanket a room like this and respond to all of the probe requests that are happening and not fall over. And like if you look at things like host APD WPE, it's got Karma in. And what that does, like the way it changes beacons, it doesn't scale beyond 2 or 3 devices, or it certainly doesn't scale beyond 5 devices. Like Mana can do a room, it can handle, I haven't done like extensive tests, but like if there's 100 devices, it's not going to fall over. It becomes more of an RF problem. There's something called the hidden node problem. So if you can imagine, if I'm standing next to you screaming, you're probably not going to be able to hear the person whispering at the background. Similarly, if I've got an access point here that's screaming probes at everyone, it's probably not going to hear somebody in the back of the room. So that's why I say use enterprise APs and make sure you place things correctly. But one of the problems we ran into is this concept of proportionality. I mean, it would be illegal to target people who aren't in scope for the penetration test. So we built some proportionality options in. So there's some really obvious proportionality options, so like SSID whitelisting, things like that. But the one I'm really proud of is management frame ACLs. So any of you who've configured a wireless network before will know at your home you've got the option to restrict by MAC address who can associate to it. And anyone who's done Wi-Fi hacking before will know that's a really stupid restriction because you can just go into monitor mode and see what the MAC address is and connect. And then even people whose MAC addresses aren't authorized, they'll still see that network in their list. They'll look at their phone and there's your home network there. And you can make it hidden, but then the devices end up probing for the network the whole time. So you end up with a sort of imperfect world. So what I did is I extended MAC address ACLs down to the management frames. So what that means is if your MAC address is either blacklisted or not in the whitelist, then Mana won't even respond to your probe request. It's just going to ignore your probe requests. So that means that it's not going to see that network even show up. And on the flip side, an allowed device will. But the other problem we run into is, well, these randomized MAC addresses, if you only whitelist the MAC addresses of the people you're targeting, the randomized MAC addresses are going to be blacklisted. And that's a problem. So if you've ever played with advanced options in AeroDump, they've got this idea of like a binary net mask that you can apply to MAC addresses. So I brought that into the general ACL for host APD, so you can use it at the association level or at this management frame level. And so you can say, for example, all randomized MAC addresses are whitelisted, but then only this MAC address is whitelisted to associate. But depending on the randomization that's being used, so like Windows will randomize per network, whereas Mac or iOS devices will randomize per probe that they're doing. So you can choose your strategy based on what you're targeting. But with that means that you can sort of, for example, do partial loud mode. Hey, I want to see and respond to every probe, but only allow this device to associate. And even though it's responding to the randomized MAC addresses, you'll still only the allowed device on a Mac or an iOS device will see that network show up in their allowed network list. So that's also really great if it's like historically running loud mode was really obvious to any security people who might be watching you because they'd see like 200 networks appear in the nearby network list. Now you can hide that from them. Or if there's wireless intrusion prevention systems, you can hide this stuff from them. And nobody has implemented this anywhere. I don't know why. So it looks different enough that you can, most wireless intrusion prevention systems haven't caught up with it. You can kind of hide in plain sight. All right, now the other problem I think that people have with Wi-Fi hacking is you've got to buy hardware and you've got to make sure you're like running afoul of FCC laws and things like that. It's just kind of hard to get into. And then you buy the latest Alpha Black at Defcon and it turns out it doesn't work with Mana stuff because of the way the firmware runs on the device rather than on the software. For what it's worth, on the wiki, it's got a list of hardware that works with this stuff, or is at least known to work or partially works. So Michael, the guy that I did this with, he's a kendo nerd, and if you are a kendo nerd too, you'll know that those wooden bamboo swords are called shinais. So they're practice swords. You're not going to cut someone's ear off. You just like hit their stupid thing that they're wearing. As you can tell, I have deep respect for kendo. I'm sorry. So a couple of years ago, we do a bunch of commercial trainings, and we invented the stuff we called Wi-Fi in the cloud, which is our challenge was how do we present AWS environments to students so that they could practice Wi-Fi hacking without actually giving them hardware and making the stuff repeatable. So we came up with stuff that worked. And I'm still sort of amazed that it does work. But the problem was it was kind of burrowed away in our commercial training. So I've created a Docker image called Shinai-Fi, and it allows you to practice Wi-Fi hacking without needing any hardware. So it uses a module, a Linux kernel module called Mac 802.11_HWSIM. So if you're running Linux yourself, you can just mod probe that module in. It's part of the default kernel. It's nothing fancy. And then you get these two simulated hardware devices, wireless devices. If you're running Kali, that stuff works out of the box. If you're running Docker on Windows or Mac, it's a little more complicated because they use an interstitial VM, effectively, that functions as the Docker host, and you've got to rebuild the kernel, and I may have gotten a cease and desist from Docker telling me not to do the reverse engineering on their stuff. You may be able to ignore that on github.com/Sinj. But anyway, just run it on a Linux VM. It'll make your life easier. But all you do is you would do docker pull singlet/Shinai-Fi. You can grab it right now, and then this is that container running with no hardware attached to it. So I'm saying, show me a Wi-Fi adapter. You can see there's a Wi-Fi adapter. And I then put it into monitor mode. I mean, this is bog standard. Is that 10 minutes? OK. I thought you just want to double high fives. Yeah. Okay, so putting it into monitor mode, and you can see there it says software simulated of 802.11 radios, and then we run error dump, so this would normally show you traffic nearby, which it's doing, even though this is all fake. So in the back end, I've got like cron jobs and TCP replay, but the stuff's surprisingly robust, like it actually works, and I've run it for enough years that I've figured out all of the weird states that things get into. So yeah, if you want to, this is, again, the Docker file is all on our GitHub. You can check out how it's put together if you want to build your own CTFs using this stuff. And you just literally replace the cap file, and from a monitor mode level, you'd get this. But it's also got, like if you run an access point, clients will try and connect to you with PEEP and things like that. So you can practice a whole bunch of this stuff without needing the actual hardware. I'm hoping it gets more people into Wi-Fi hacking. Where are we here? That was just my screenshot in case the video didn't work. Okay, so that's the kind of the end of our talk. Like I said, the wifi.net is where you can get this. I'm from SensePost, and those are our Twitter handles. And really, what I'd ideally like to take away from this is, on the one hand, this is how like modern Wi-Fi hacking needs to happen. We can't rely on some of the old stuff. It's going to be very rogue access point based. But more importantly, what I'd like to take is that go and tinker with this stuff. It works really well. If you're a defender, figure out where your networks are vulnerable. Like PEEP is not the way to go, and EAP-TLS is not a panacea. Understand those constraints and build better networks by targeting yourself. And if you're a penetration tester, then you should absolutely be using this because it works against enterprise networks. And if you want to get into penetration testing, Wi-Fi is a really easy, accessible way to get into this. And it's like a lifelong field if you're interested in the specifics of this. So thank you very much for your time, and thank you, Hackfest, for having me. Anyone want to ask any questions? Anyone want to throw any rotten fruit? Canadians are both too polite to ask questions or throw fruit. Okay, otherwise I'll be here afterwards if you want to talk about it. Thank you.